There's one. I'll keep you busy for a minute or two. Alright, that's probably long enough. So the first thing is you have to realize how you're going to do this integral. So you look at this, you say, well, first trick I know is u substitution. This can't be u substitution because the derivative of the e term is not the cosine term, and the derivative of the cosine term is not the e term, so I guess I'm going to do integration by parts. So let's let u equal, doesn't matter which one you pick, e to the 2x, then dv would equal cosine 3x dx. And du is 2e to the 2x dx. V is sine of 3x over 3. So this is going to get messy with all the 2's and the 3's, so be careful. Okay. So now we're going to have integral of e to the 2x cosine 3x dx equals u times v, e to the 2x sine 3x over 3, minus the integral of v to u, which is minus, pull out the 2 and the 3, 2/3 of the integral of e to the 2x sine 3x dx. Okay? 2/3 comes from this 2 and that 3. Alright, gotta do it again. Let's let u equal e to the 2x. du is 2e to the 2x dx. dv is sine of 3x dx. And v is minus cosine 3x over 3. So that means that our integral of e to the 2x cosine 3x dx equals e to the 2x sine 3x over 3 minus, now we have to integrate that 2/3 thing, 2/3 on the outside, u times v, which is minus e to the 2x cosine 3x over 3, minus the integral of v to u. So minus minus becomes plus 2/3 e to the 2x cosine 3x dx. So far so good? Now clean it up. So this becomes e to the 2x sine 3x over 3. Minus minus becomes plus 2/9 e to the 2x cosine 3x minus 4/9 integral e to the 2x cosine 3x dx. At this point, you're questioning the entire medical school idea. Now, that is equal to the integral of e to the 2x cosine 3x dx. Okay? So you've seen the more generic one with just e to the x sine x and e to the x cosine x. You just make it harder if you throw in some constants. You can make it really fun if we threw in things like pi. But we wouldn't do that to you. Alright, so now you notice I have 1 e to the 2x cosine 3x over there, and I have 4/9 of 1 here. So if I add it to the other side, I will get 13/9 the integral of e to the 2x cosine 3x dx equals e to the 2x sine 3x over 3 plus 2/9 e to the 2x cosine 3x plus a constant, and then you can just multiply everything by 9/13. Okay? So you would get 9/13 of this thing, which you would not have to simplify. Okay, how are you doing this one? Anybody get it? Good, you get close. You got close, that's okay. All right. Give you guys a minute more to copy that down. Remember, it'll be on the video. The video for this class will go up probably Friday, maybe tomorrow afternoon. Okay? So one of the things you should do to review for the final is go through your midterms. Go through the 2 practice sets for the 2 midterms. I don't know if we'll have more practice for the final, but we'll try. Okay? So you do that integral. Alright, that's long enough. So when you see these trig ones, you really want to look for using some trig identities to simplify things. So when you have sines and you have cosines, remember that the derivative of sine is cosine. So you kind of have a function in this derivative. The problem is you have too many cosines or too many sines. But one thing we could do is we could rewrite this as sine to the 5th x cosine squared x cosine x dx. Why would we want to do that? We would want to do that because now we would have a single cosine, which is derivative of sine, if we could just find a way to get rid of the other cosines. But then we remember our trigonometry, or MAT 123, and you know that this is the integral of sine to the 5th x times cosine squared is 1 minus sine squared x cosine x dx. Now, you can do u substitution. So you let u equal sine x, du is cosine x dx. So this integral now becomes u to the 5th, 1 minus u squared, du. Okay, that's a much easier integral. Distribute the u to the 5th. You get u to the 5th minus u to the 7th du, which is u to the 6th over 6 minus u to the 8th over 8 plus a constant. And then substitute back. And you get sine to the 6th x over 6 minus sine to the 8th x over 8 plus c. You do that one okay? No? Yes? The trick is you have to see to take out 2 of the cosines. Okay? Now, by the way, you could have taken sine to the 5th and made it sine times sine to the 4th, and made that sine squared times sine squared, done everything in terms of cosines. It's just more work, but you certainly could have done that. Okay? So far, so good? Let's give you another one. We're having way too much fun today. I'll put it over there. That's going to be my starting spot. Yay! One of these. So you got 11x squared plus 8x plus 5 in the numerator. You have 2x plus 1 times x squared plus 1 in the denominator. Be thankful we didn't make you factor that. Integrate it. Just to give you guys your first step. You're going to want some a over 2x plus 1 plus bx plus c over x squared plus 1. Or you could switch the letters around a bit. Alright, when it gets this noisy, that means people are done. So let's start doing this. Alright, so first, we have a over 2x plus 1 plus bx plus c over x squared plus 1. And that has to equal this thing. Which means if we multiply through by the denominator, we will end up with a times x squared plus 1 plus bx plus c times 2x plus 1 equals 11x squared plus 8x plus 5. Okay? So now let's do some algebra. So FOIL out the left side, and you're going to get ax squared plus a plus 2bx squared plus bx plus 2cx plus c equals 11x squared plus 8x plus 5. Okay, so that becomes a plus 2b x squared plus b plus 2c x plus a plus c is 11x squared plus 8x plus 5. See, in that cover-up method that your teachers taught you in school starts to fail on these kind of problems. Sometimes. Alright, this tells us that a plus 2b has to equal 11, b plus 2c equals 8, and a plus c equals 5. Now, you can just sort of guess, right? Maybe you can come up with the right numbers. Or the simplest thing for these is get rid of one of the variables and put it into the equations together too, so you get down to two equations and two variables. For example, here you could say c is 5 minus a. And now you would have a plus 2b equals 11, and b plus 2 times 5 minus a equals 8. So that's a plus 2b equals 11, and b minus 2a equals negative 2, skipping a step. Okay, now I gotta solve that one. So you could either now do something clever like multiply this equation by 2 and add them, or you could do substitution again. So I'm going to multiply it by 2. That's pretty easy. So this becomes 2a plus 4b equals 22, and minus 2a plus b equals minus 2. And now when I add them, I get 5b is 20, so b equals 4. Now that we know that b equals 4, we can go find the other two things. So a plus 2b is 11, so a equals 3, b equals 4, and c equals 2. How are we doing that? Alright, so that means that we can take our integral and now rewrite it as 3 over 2x plus 1 dx plus 4x plus 2 over x squared plus 1 dx, or 3 the integral of dx over 2x plus 1 plus 4 the integral of dx over x dx over x squared plus 1 plus 2 the integral dx over x squared plus 1. A lot of work. Okay, so far so good? Okay. These two are straightforward. This one takes a tiny bit of work. So let u equal x squared plus 1, du is 2x dx, so a half du is x dx. So that middle integral becomes 4 times 1/2 integral du over u. I told you guys earlier, I recommend you just memorize how to do this integral. That integral becomes 1/2 the natural log of x squared plus 1. So we are going to get 3 times natural log of 2x plus 1 over 2 plus 2 natural log x squared plus 1 plus 2 tan inverse of x plus a constant. How do we do? Yay? Med school? Yes?
Can you explain that last part?
Which last part?
Where you did the u sub?
Sure. Let u equal x squared plus 1. Du is 2x. So when you substitute here, you've got x dx, so I need a half of du. So I get 4 times 1/2 du over u.
Oh.
4 times a half is 2. So I recommend, because we might have one of these in the final, we might not, I don't really remember. But if you have the integral of x dx over x squared plus 1, just remember that that's a half ln x squared plus 1. You don't need the absolute value bars because x squared plus 1 is always positive. Alright? Let's see if you guys have something else to work on.
I still said $6. I'll pay you for where you just get back.
Okay. So we have the region between y equals 25 minus x squared and y equals 25 minus 5x. Find the area of R, the volume when it's revolved about the y-axis using shells, and about the x-axis using washes. Let R be the region bounded by y equals 25 minus x squared and y equals 25 minus 5x. So first, let's draw a picture. I'm pretty sure that we will actually give you the picture on the exam. But your region looks something like that. This is the piece of the parabola that will matter, right? This actually sort of keeps going like that. So this is 25 minus 5x squared, and minus x squared, sorry. And this is 25 minus 5x. Guys, everyone draw the picture? Okay. Area simply equals the integral from here to here of our slices. So where do they intersect? Well, this is 25. This is 0, 25. This is 5, 0. So we're going to integrate from x equals 0 to x equals 5, top curve squared, top curve minus bottom curve dx. I'm not really that interested in you doing the actual integration, but since we're here, the integral from 0 to 5 of 5x minus x squared. How am I doing? So far, so good? That equals 5x squared over 2 minus x cubed over 3 from 0 to 5, and that equals 125 over 6. Right? We all get 125 over 6. We're 20 and 5/6. We're 20.833, or I give up. Any of those? The last one. Okay. B. Let's find volume. So if we want to go around the y-axis, we're going to get a cylindrical shell because we take a slice like here, we're going to get that shell shape. Okay? The height of the shell will be the slice going from the top curve to the bottom curve. The radius of the shell will just be x. X determines where you do the slice. You go out x, and then you slice it. So the volume will be 2 pi, integral from 0 to 5, so x times 25 minus x squared minus 25 minus 5x dx. That equals 2 pi integral from 0 to 5 of 5x squared minus x cubed dx. So far so good? What? That's coming. Gotta be patient. Alright. Now, that integral is 2 pi times 5x cubed over 3 minus x to the fourth over 4 from 0 to 5. And that equals 625, 1350 pi over 12. Which can be reduced. Right? 104.16 pi. Something like that. 166. Something like that. I'm wrong a lot. So far, so good? Alright, C. Now, I want to do around the x-axis. So to redraw this picture for a second. Now, if I were going around the x-axis, I'm not going to get the same answer. So now, if I slice this way, I will get a washer. So the volume is pi r squared. So the volume is going to be pi, to go from 0 to 5, of the top curve squared. That's 25 minus x squared, squared minus the bottom curve squared. So, I don't really think we'll ask you to evaluate this because these get annoying, but 625 minus 50 x squared plus x to the fourth minus 625 plus 250x minus 25x squared dx, which is pi, so you can go from 0 to 5, of x to the fourth minus 75x squared plus 250x. You guys get that? Yes. Well, if I wanted to change in terms of x in terms of y, so for example, if I wanted to do shells around the x-axis, then I'd have to slice this way. Okay? But then if I'm slicing that way, I'm now doing things in terms of y, so I have to convert the equation from x to y. Similarly, if I was going around the y-axis and I wanted to do washers, I'd have to have that slice. So if I'm going to slice horizontally, it has to be in terms of y. If I'm going to slice vertically, it has to be in terms of x. Notice I haven't spent a lot of time on that. Okay. Alright, let's give you guys another kind of problem. There's still time. x equals 1 to x equals 5, using a equals 4 right-hand rectangles, then write, but do not evaluate, the Riemann sum. Alright, this one should be easier. We'll see if that's true. No? 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 Oh gosh, folks, you've got to remember this stuff. Okay, you have a week. You do have a week, right? Well, you're just under a week. The exam's at 8 in the morning. It's 5 in the afternoon. That's 150. It's 11. Right. So, some of you will be studying at 10:30. So you still have 162 hours. Subtract 2 hours a day for sleep. Which I do not suggest. Alright, let's get this one done. So first of all, you should know how to find the answer, okay? Because the answer is just the integral from 1 to 5 of x squared plus 3 dx, which is x cubed over 3 plus 3x from 1 to 5, 125 over 3 plus 15, minus a third plus 3, which is 170 over 3, times 10 over 3, 160 over 3. So when you do a problem like this, do the integral first so you know what you're dealing with. Alright. So let's do n equals 4 right-hand rectangles. So x squared plus 3 is something boring like that. We're going from 1 to 5. We're going to go from 1 to 5. And we're going to use right-hand rectangles. So the width of each of these rectangles is 1. You go from 1 to 5, that's a distance of 4. So the width is 5 minus 1 over 4 equals 4. The height is f at 2, f at 3, f at 4, and f at 5. So the area is going to be, I'm sorry, that's not 4, that's 1, excuse me. 1 times f at 2 plus f at 3 plus f at 4 plus f at 5. And we're going to overstate the area. So we're going to come out with something bigger than 160 over 3. So what is that? Well, let's see. F at 2 is 2 squared plus 3. F at 3 is 3 squared plus 3. F at 4 is 4 squared plus 3. And F at 5 is 5 squared plus 3. I don't really care what this comes out, but this is 66, which is bigger than 160 over 3. So were we able to execute part A? No, because you forgot it. Okay. Well, you got a week to remember it. A week minus about 6 hours. It's not like you have nothing else to study. The only course you take is math, right? Okay, good. Alright. Now to do the Riemann sum, all you want to do is say, well, how wide is each one of these? Well, instead of being 4 over 4, which is 1, it's now going to be 4 over n. And you're going to start at 1, and you're going to add 4 over n each time. Oops, sorry. So you're going to do f of 1 plus 4 over n. Then you're going to do f of 1 plus 2 times 4 over n. Then you're going to do f of 1 plus 3 times 4 over n. And you can go up to f of 1 plus n times 4 over n. So if you're making that that fancy sigma thing, it's going to be from I equals 1 to n of 4 over n times f at 1 plus 4 I over n. In other words, 1 plus 4i over n squared plus 3. And you do the limit as n goes to infinity. So again, this comes from x squared plus 3. You essentially take that first insert into the parentheses, stick an I in there. Okay? Because each time you're taking this 4 over n and you're multiplying it by a bigger and bigger number, starting at 1, getting up to n. Yes? So if I say set up the Riemann sum, I am looking for this. Okay, folks? Alright, look for stuff on Blackboard. Good luck. You guys were a great class. Have a wonderful summer if I don't see you.